Hello, this is simply about networking protocols, and today I'll tell you about IGMP and MLD. Standards that describing different versions of IGMP and MLD are on the screen. I recommend to start with RFC 1112. In this video, I'll tell you about IP multicast and non-IP, L2 multicast, IGMP and MLD query, IGMP and MLD join, and IGMP leave and MLD done. Well, as you remember from previous video about multicast is like a samurai. It has no goal, specific goal. It has only path. And the main idea is to build some database that allows to point out necessary path for the multicast. As you remember, from Mac perspective, L2 point of view, Mac multicasts are those that have odd first byte. It means 0, 1, 2, 1, 3, 1, 0, 3, 2, 3, 3, 3, and so on and so forth. First byte is odd. Then it means Mac is multicast. But from IP perspective, for v4, we have range of IP addresses starting with 224 TL239, and from v6 perspective, we have all the range of FF starting IP addresses starting with FF. And those specific IP multicasts have mapping to the Mac. So there is a request to map them specifically to specific multicast address, Mac multicast address, and it's performed in the following way. For v4, 224 or TL239 are transferred to the 01005E. Then first bit in Boolean representation of the IP v4 address is 0, force 0, even if in original address it's 1, it's 0. And then all bits are transferred as is, so actual multicast mark for IP multicast will look like 01 to 05E, something between 00 till 7F, and then hexadecimal representation of the last 2 bytes of IP address. For IPv6, transfer is a little bit simpler. It's 3333, and last 4 bytes of the IPv6 multicast address are transferred into Mac directly because they are in hexadecimal actually. And protocols that are designed to build mapping for next destination starting from this device, from next neighbor starting from this device who want to receive specific multicast address. For IPv4 is IGMP, and for IPv6 is MLD. They have a little bit more differences, but in basics they are the same. And I'm talking here about basics. So we have IP Mac and IGMP and other multicast routing protocols working with those IP addresses and Macs. And what about other range of multicast Macs that are not IP? Well, they are non-IP. They are handled on L2 level. They are handled by so-called filtering database. Thus, they also can be somehow partially processed by specific protocols like IGMP snooping, but this is not the target of our video today. And most of them are processed by specific protocols like MMRP of MRP protocols family, or GMRP from GARP protocols family, or configured administratively. So since IGMP and MLD are protocols, they have control traffic. And control traffic has specific representation of IP and MAC addresses, reserved IP and MAC addresses. For IGMP, it's 224.0.0.1. That is by this rule transferred into 01005E 000001. This is general query. Group specific query that has values from this specific group. Remember that everything here is called group in IP address. Join and leave done. Leave for IGMP, done for MLD. This address called all routes address. And how it looks. So again, IGMP and MLD supposed to build database that tells behind which interfaces we have behind which interfaces we have devices that would like to receive multicast traffic. We don't know how many devices there are. We don't know which devices are. We know only direction, and we are building this map of directions per group. Each router starts as query. Per specification, in subnet, in physical network, can be only one query, but every router starts as query and sends out from each interface that is configured to participate in IGMP or IP multicast general queries. IGMP general queries. Those are needed to receive information from neighbors that they would like to receive multicast traffic of specific group in their direction. Well, device router can work also in non-query mode. They selected by communication between routers in the same physical network. The difference between query and non-query: query generates queries, while non-query, as you understand, doesn't. It only processes queries that received from query. So we have our query that sends general queries. Those are general queries. In order to receive information about groups that our neighbors would like to receive, this information is provided by join packet. In this packet is specified special exact group that needs to be forwarded behind this interface, that our neighbor would like to receive needs to be forwarded behind this interface. Only directions. We don't know nothing about neighbors. We only receive joins, and where we receive these joins, we remembering that behind this interface someone wants to receive multicast traffic specified for this group. Then this is actually our multicast group membership database, behind which interface we should send copy of multicast traffic of specific group. In case we receive general query from querier on our router, we preparing information about which groups we would like to receive on this interface and sending this information by joins from our table. That's simple. The specific is that those joins need to be sent, since joins are sent per group. So for each group we need to send a join. There could be many joins, so they are sent in in different order each time, in order to minimize probability of the losing some information here. This process is periodic, so we as a querier periodically send general queries, non-queries receiving them and regenerate general queries, and so on and so forth. So information is time-outed on each interface and in database. So each period of time, we send in general query to each interface in our network in order to receive joins and approve that there's still some device that would like to receive information behind this interface. In case for some time we didn't receive this information, we're cleaning this group membership for the interface, and sending leave or done depends on are we IGMP or MLD. Talking a little bit more about leave and done. So until we're after sending query, general query, and until timeout ends for receiving join, multicast traffic will be sent behind this interface. In order to reduce this time of sending unnecessary multicast to unnecessary direction, we're using leave or done depends on IGMP or MLD, and it works in the following way. When we receive leave on some interface, it means that member of this group that behind our interface wants to leave, doesn't want to receive multicast information anymore. Then we start in specific procedure, starting another timer, much less timer, and sending group specific queries from this interface, because again we don't have any information about how many devices would like to receive this multicast traffic, which those devices are, and so on and so forth. So in case there is some complicated configuration out there and we received traffic from one member, but there is still some member of this group that would like to receive this information, we send in packets that to notify. So those packets are generally a question: is there anyone who still wants to be joined to this group, wants to receive this traffic? If anyone replies with join, this timer is stopped, we renew this information, and nothing happens. But if during this small timeout a join is not received, we realize that there is no more members for this group behind this interface. We need to clean this information, and we cleaning this information from database and do not forward data traffic there anymore for this specific group. If on our device this was the last member of this specific group for any reason, we sending leave or done message to our query device saying that we would like to leave this group, no need to send us data traffic anymore, to reduce the period, this period when we still receive multicast traffic. And this procedure repeats, but now our neighbor device, our query, is one who generates group-specific query asking, is there by the chance anyone who would like to receive this information? And if we really don't have any more members on this interface, we're not replying. And then this device will drop this information on its interfaces. Or if by some chance we still have some interfaces where this information is required, we send in join and everything is fine. This how we're building and keeping up to date a IGMP table or MLD table of multicast group membership per router. That simple. Have a good day.